And what I'd like to do now is to introduce our next presenter, Simon Eley, who is a Principal Systems Engineer with the BBC. Simon is a chartered engineer who's worked substantial experience in radio spectrum aspects and broadcast engineering in live broadcast environments, covered a lot of activities. His practical knowledge embraces vision, sound, satellite systems, terrestrial wireless networks, broadcast delivery, managing complex multidisciplinary projects. He's participated in and contributed to many international technical groups and standard bodies on behalf of several high-profile commercial and public organisations, I'm sure including the BBC. And so without more ado, I'd like to pass over to Simon, who's going to be presenting to us on some of the aspects of content production opportunities for NR+. Over to you, Simon. Thank you.
Thank you, Walter, and good afternoon, everybody. Right, are you seeing my screen?
Yes.
In my presentation? Good. Okay, right, excellent. Yes, I was going to talk to you today a little bit about the opportunities for NR+ in content production, which isn't all fully understood, but the previous speaker has talked about industrial applications, and there are other applications in medical and business, but my concentration is on content production, and I'm going to look at the opportunities here. Firstly, defining what content production is. What is PMSE, Program Making and Special Events, which is a term used that you may hear a lot and it helps to understand. And how does content production work right now? And then how is it changing? And where does NR+ fit into the future of content production? So hopefully it gives you a background on where NR+ might apply, perhaps some of the crossover characteristics with applications unrelated to content production, but some synergies there that you may find interesting. So what is it? Well, fundamentally it's TV, audio and feature film production, it's live music, it's events and theatre production, and also news gathering, which I want to come back to, and some examples here on the right with wireless cameras, wireless microphones, big festivals where you get a lot of radio microphones and monitor systems, and TV and film production. And the wireless use in content production is termed Program Making and Special Events, which is shortened to PMSE, and that's what you may see in a lot of the documentation and in a lot of the groups that look after this area. And I'll put this, there's a description here which you can read if you look at from the slides later on, but it just describes everything that comes under PMSE. And to expand a little bit more on PMSE and what I do and how it all fits together, this is a graphic I use to explain it to colleagues, and it broadly falls into four areas. You've got international spectrum, domestic spectrum, operational RF support and technology developments. A bit UK-centric, but you can apply it to your own country. So in the international field, for example, you have the CPT, and ETSI, the EBU, and the ITU-R, who look after the international spectrum for program making and special events. You have a domestic spectrum organisation, which will look after licenses and clearances. They will look at consultations and spectrum policies. And there'll be, in the UK, for example, I attend regular technical groups and other trade events and industry bodies to keep up with developments. There's an operational RF support to my role, which is talking to my operational colleagues who look after news gathering and major sport and national events, who operate the studio equipment and infrastructure, a little bit of safety on electromagnetic fields, because that is an area, look into interference where it happens, and help out with projects and specifying design in those. And then looking to the future, there's the technology developments, which includes 5G and NR+ and others. And this is where I came into the DECT Forum, for example, through industry groups, and look after some technology trials as well to trial new technologies. So that gives you a background of PMSE and a little bit about what I do. So how does it work now? Well, currently we have multiple unidirectional radio channels. And for example, we have audio PMSE, which is in-ear monitor systems, radio microphones, audio links, and they typically operate in the range 470 to 694 megahertz, sharing with digital television. Then we have video PMSE, which includes airborne video links, cordless cameras, point-to-point video links, and they generally operate in the ranges 2 to 8 gigahertz. And then we have service links, which are maybe a little less understood, which include perhaps talkback and data control, and they're across various bands. And the example I have here is a camera used for coverage of live fireworks in the UK on New Year's Eve. And these are fireworks over a very wide area, which can't be cabled. So you've got wireless video links, but you've also got wireless control of data back to them. So the device that I've highlighted here will control the iris and the color balance and the like remotely, and those are very important. But fundamentally, these are unidirectional radio channels, which all have to be made to work together. And you get a high demand for spectrum at sporting and major events. You can see on the left there a TV compound for a major golf event. You can see in the middle a whole range of wireless camera antennas which roam across the course, and you need to be able to get pictures from literally any point on the course. And on the right you have a cricket match, which shows that there's often a lot of other users there, including the public in the crowd, a lot of RF use for the production. Now, in audio PMSE, which is the radio mics and monitors, you have outdoor music events, and here's an example of Glastonbury. And you have wireless instrument packs, you have radio microphones, you have in-ear monitors, and you've got multiple bands on multiple stages, and they're all operating at the same time. So it's high spectrum demand. So this is what's required. This is required to be met, all this huge demand. And just to give you some numbers on that, we have these are some figures I put together for a WRC document. And if you took a major filmmaking production centre or TV production centres, you may have 200 devices operating it simultaneously across a number of sound stages or studios, and that in the UHF band might take 82 megahertz of spectrum, which may or may not be available still. A large theatre production may have up almost 94, well, I've put 94, but up to 100 or more radio mics and monitors. This is equipment sewn into costumes that you can't, so you may have more channels than performers or characters, and you may have many theatres in a part of the next door in a theatre quarter, for example. So a big demand in a small area. The outdoor music event I mentioned, that could be anything up to 260 devices, and then TV news gathering, which is less use, but potentially anywhere at any time with no notice. So that's a very important use of PMSE. And then a TV sporting event where you may have high power microphones on the golf course, or lots of devices across to control what's going on. And just to show that this is demand, the demand is everywhere. In the UK, we have a system which is quite well developed in licensing. So it shows that the locations where people go, and it literally is everywhere. So as you can see from this, and these are the instances over a couple of years. So the spectrum and its use and its availability is universal. And I'd say that was the same for most countries. So there's a particular quality of service required, but what does quality of service mean for program making and special events and content production in particular? Well, we need guaranteed robust bandwidth, video and audio quality. These are performances which could well be live. There's no chance to redo. The audience are very intolerant of breakup and the like, so that's vitally important. We need low and reliable latency. We need to be able to mix various sources and know the latencies so that they can be co-timed. And we need suitable spectrum solutions for devices, so antennas are of a certain size. We need to be able to take advantage of propagation over short ranges or long distances accordingly. And they need to be in suitable body-worn devices, particularly for audio, and the battery performance needs to be good as well. We can't be taking equipment off performers regularly to change batteries. But currently, this has only been able to be achieved through using bespoke and proprietary systems, relatively small markets, and relatively small production runs. That's been a very niche part of the program making equipment industry. One particular quality of service requirement I want to mention, because it's vital for content production, and you may see it, this may echo in other areas of industrial or medical applications. If you have, for example, a performer on stage using a radio microphone, their voice will be through a monitor desk, as you can see, and then it's returned via wireless to the performer's ear. But because the performer is hearing themselves back, the round-trip latency needs to be less than 4 milliseconds, and that's quite a challenge with the current technologies. And that's part of the reason why analog FM has been used for so long, because its processing is very brief. It's very simple. But that is a figure that is worth keeping in mind when it comes to the development of NR+. The conventional DECT is already used in PMSE for production talkback, and here's a couple of sets of examples that you'll find across BBC studios. It has adequate audio, it has adequate latency for somebody on the floor, on a camera, or a floor manager, and involved in the production. It has the DECT license exempt spectrum, which is really useful because it can be used anywhere, and so used out on outside broadcasts at the drop of a hat. And we have the robust coverage that Walter's mentioned regarding the time slots and frequency slots sharing. And one particular application I was involved in was putting 15 sets of equipment into 15 studios in Broadcasting House in London, for example. And the question came back from the on high, well, will it work? I mean, all this equipment together. And with a DECT monitor, I was very pleasantly surprised to see that the way that the robustness of the system worked, that it didn't fall over. It was very, first and still is, very reliable. And of course it's secure. It can't be listened to by anybody who's not on the system. So what are the trends then? Well, we've got in content production, much of it is wired and it's using IP-based workflows. So this is IP-based video, audio, moving around in production centers and between outside broadcasts and studio centers. There are more cloud-based bidirectional workflows coming down the road, and this is where content would be not necessarily managed on site. It may go back to a base, it may go to a server farm, there may be processing and effects and used for that. And there's the opportunity to use more scalable IP-based resources if we're using IP-based workflows. So that's server farms according to what you need, and you can scale it up as requirements change or down. But the conventional wireless production is still not easily integrated into the IP workflows. It's this bespoke proprietary systems which are unidirectional, which don't necessarily fit in. So what can 5G and NR+ offer? 5G as a non-cellular 5G system. Well, it can offer common network technologies at lower cost. It can be more flexible, enhance facilities and interoperability. We've seen that in the IT industry. And there's the opportunity to use mass market chipsets compared with the traditional bespoke PMSE equipments. And we can achieve the low latency and reliability to match traditional PMSE. We hope that's the aim. So what challenges do we have in doing that? Well, we need equipment and system integration. Colleagues have put prototypes together at the moment. Right now, this is a prototype in one of our labs, which mimics what might go on the back of a wireless camera, for example. But obviously, it's not in a practical state yet. We need to be able to configure these systems for high upload versus download. As you can imagine, 5G type systems are optimized for fast download because that's what the public model is down to customers, whereas the content production needs high upload for its content. And we haven't found particularly good RS performance yet on some of the products, so there's work to be done there. And then there's connectivity and spectrum solutions. Yes, you've got public networks, but there's not much progress so far other than best efforts. We can look into network slicing, where a public telco gives you a guaranteed slice of the network, and perhaps might be able to adjust the upload versus the downlink for you. But public networks, so far there's been a slow rollout of universal standalone 5G. That's the 5G radio and the 5G core. We're not quite there yet on that. And that relates obviously to quality of service, which we need for our content production. So one option is non-public networks, and this is where NR+ can be termed a non-public network. It's in its own spectrum. You can guarantee your quality of service. You can decide for yourself within your own network what the quality of service is going to be. You can optimize your upload and download speeds in this dedicated spectrum, and it's more secure than public networks. You've got more control. But you need for that short-term or short-notice spectrum leasing beyond the existing DECT bands, and that's rare around the world. Network operators with a lot of the spectrum have got little incentive to engage at the moment. They have their own networks to run, and adjusting their networks for a short time and a short notice is not something they are inclined to do. And regulators themselves are finding it too difficult to contemplate at the moment, finding spectrum for these applications. So how's it being addressed? Well, we know about the equipment standardization, and there's the 3GPP standards, and ITU-R has been adopted by ITU-R. Sorry, NR+ has been adopted by ITU-R. And these are all the various aspects, but I'll pick out a few of those that will be interesting to you. 3GPP release 17 addresses dynamic spectrum sharing. That's good to know. It addresses low latency. That's what we want. Network slicing, yes, let's see how that can go and what we all understand it to be and how it might work. And non-public networks as well. So that's really good. And the work continues into release 18. So that standardization work is something that's continuing. So in terms of system integration, what do you require for a non-public network? You require, for system integration, you've got 5G MAG, which is a group looking into the requirements for non-public networks. It's contributing to the release, and it's arranging trials and demonstrations. This is a group of media professionals, and they're looking into that right now. Similarly, under the EBU, you've got a 5G records group, which is integrating 5G components under 3 use cases. You've got a live audio production, you've got multiple camera wireless studio, or live immersive production. So you've got that's a combination of manufacturers, telco providers, broadcasters, and content providers. So yes, and they're working together to get that work done, and I'm part of that myself. So just to summarize the connectivity and spectrum dilemma, here's a graphic that's come out of 5G records, which sort of gives you the what needs to be prioritized in terms of, you've got best effort, which is your public networks, which yes, you've got less control, but they're more ad hoc. You can use them when you like, and they're available over a wide area. You've got then, as you move towards that, you've got a traffic prioritization, perhaps network slicing, and then you might have a PNI NPN, which is a public network integrated non-public network. So that's a non-public network provided by a public network, which is a sort of halfway house. And as you move towards the non-public networks, you've got more control, but obviously they need to be more planned and they're more defined in area. So we need to consider a commercial business model for this. As we said, the public telcos remain to be convinced. We need to crack the international regulatory framework for spectrum and how this is going to fit in. And we need to explore suitable forms of licensing, perhaps a general authorization, perhaps a secondary to an incumbent, to a telco provider. Perhaps you've got individual local area licensing, or there may be some form of spectrum leasing or trading. So where do we go next? We've got NR+, which is the first non-cellular 5G technology standard, and the opportunity to use that in content production. It already has its own exclusive spectrum, and that's very vital. We've seen that in the production talkback that is used now and is very well respected. And the opportunity now is to expand into the 5G NR bands, and that might give you the capacity to manage the greater, higher capacity events, such as the big concerts and the film and TV production centres. And it can deliver ultra reliable low latency communications for program making, industrial applications and business, medical and standalone networks. You may see the synergy with your own industries of content production. So those are the opportunities there, and I hope this has given you an idea of how content production fits into that, and a bit more about the constraints that us broadcasters and program makers operate under.